I'm Anil Kumar, and in this video we will understand how the sinusoidal functions get affected when we translate them vertically. I'm also thinking of adding reflection in this part of the video. So we'll do both the things. So reflection and vertical translations, right? We have already considered the effect of change in amplitude by vertical stretch and the time period, right? So we will now look into two parts, which are reflection and vertical translation. As you know, sine function, whenever I say sketch a sine function, I'm going to sketch it using 5 points, right? And my 5 points are when the time period is t, which in a sine function, let us say this is our sine x, right? So we have graph of y equals to sine x. That means the time period is 360 degrees. Let me write this time. And this is 180 degrees. Then we have 90 degrees here, and that is 270 degrees, correct? And maximum is 1, minimum is -1. When I say 5 points, these are my 5 critical points or key points which we'll always consider for transformations and most of our discussions. Okay, so this is the basic sine function. Let us see what happens when it is translated. Okay, so when it is translated, we'll sketch it on different scales. So let this be 2 examples for us. So let me give you one example, and let us say the function is f of x equals to sine x plus 1. Now plus 1 means that we are going to move it 1 unit up. So that is my sine function. I am adding 1, that is the y value. Do you see that is the y value which gets added up. So every point moves up by 1 unit. So if I move this point up by 1 unit, it will come right there, correct? So instead of -1, the minimum point for me will be at 0 and the maximum point will move to 2, correct? So what I will have really is that the whole wave moves up by 1 unit. So I'll kind of squeeze this up here and then sketch. Okay, so let us say this is 1 for us, and so the whole thing, instead of 0, it moves to 1. So the whole wave moves 1 unit up, and so what we have here is kind of a function which is like this, right? So that becomes our sine wave. So rest of the things remain same. What I mean to say here is the time period is 360, as you can see, right? But what changes really here is range. So when we are talking about vertical translation, we are also looking into change in range. So from vertical translation, a couple of things will change. One of them is, okay, let me write down, one of them is range. Okay, let me write this range. The other one which changes is maximum and then minimum value. So these are all the values which will change when we talk about vertical translation, right? So that is it. So let me remove the word reflection from here for the time being. It is creating problem. So we will say this is the effect of vertical translation. Correct. Now we could actually go down by some units also. So if I have a sine function which is kind of let us say like this, right? So okay, now here what I've done here is I've just moved it, but I've not moved it to 1 full unit, as you can see, right? So let us say we have moved it to half, so that we have the maximum at 1.5, minimum is 0.5 for us. Now the time period is, this value is 2 pi. Can you write down the equation of this sine function? Well, of course, since the time period is same, right? Maximum, minimum has changed, amplitude remains same. Do you see that? Amplitude remains same. That means there is only vertical translation. So I could write this equation as y equals to sine x. Now this value has moved up by half, so 0.5 or half. So that is a vertical translation we are talking about, right? I hope this part is very clear. Now let me incorporate vertical translations along with reflection in this part of the video. So we'll do plus reflection. So let me first sketch the sine wave which is only reflected. Okay, so let us sketch the sine wave which is reflected. That is to say, I want to write equation. I'm writing equation as minus sine x, right? So y equals to minus sine x. That means it is reflected on x-axis. So if you reflect on x-axis, that means this is the mirror, then the sine wave will start like this. So that is how it is going to look like, and this particular sine wave is minus sine x with the same 5 critical points for us, and these points are at 0, 90 degrees, 180 degrees, 270 degrees, right, and 360 degrees. You get it. Correct. Now if I say sketch a sine function which is minus sine x minus 1, how will you do it? Well, the idea is first you reflect it as we did above, correct? So first you reflect it and then you move the axis 1 unit down. So we move the axis 1 unit down and then you sketch your function going downwards, correct? So it goes downwards and then touches this and then comes back. So that is your function, and of course the maximum minimum points will change. As you have moved minus 1 unit down, the minimum value is minus 2, maximum is 0. Earlier it was minus 1 and plus 1, correct? So that is the change which you are going to observe. However, the time period remains same, right? So that is how your time period is going to be. So I'm using 2 pi and 360 degrees as my time period. Remember, pi is equals to 180 degrees, and that is how you can actually convert from one unit to other, right? So I hope with this you understand and appreciate how to sketch sinusoidal functions after reflection, or how to even write the equation of sinusoidal function when they are translated and reflected, right? So go through this once again. As an exercise, what you can do is write domain and range for these functions. I hope that helps. When I say domain and range, domain of one cycle, right? So let me be very specific. So the question is, write domain and range for one cycle. For one cycle only, right? So one cycle domain is 2 pi in our cases. However, the range is changing since we are working on vertical translation. So whenever you do vertical stretch or vertical translation, the range will change, not the domain. That is important to understand. The other things which change along with the range is the axis. So you also notice that the second thing which changes is the axis. So always when you're doing translations, then the axis is changing and range is changing. So two things change here whenever we do vertical translations, and those two things are, let me insert somewhere here. So one is axis, right? And the other thing is range. So these are very critical points to understand, and they will help you to answer multiple choice questions, and we have a whole lot of them. Thank you and all the best.